Alright, so good news, ladies and gentlemen. Today's video is actually a bit of review. It's something that we've done numerous times throughout the semester. We're just going to be looking at it using slightly different vocabulary, so we're going to focus on the vocabulary that we're using, and we are also going to be looking at some slightly complex functions. And that's the idea. The idea is that we know how to use our graphing calculators, so we actually know how to solve any type of function we are given. Because whether we understand the function now or not, the graphing calculator is a tool that can help us identify these solutions. So what we're looking at today is to identify zeros, sketch graphs of these new types of functions, and we're just going to use our graphing calculator to do this. Our directions are going to state that we have to solve by graphing. Those aren't unfamiliar directions. But what we're talking about is that solutions are the same thing as zeros. So when you hear us, or you hear your teacher, you hear me, you hear somebody say, find the zeros. Those zeros are the same things as the solutions. What are the x values? Now they're called zeros for a very specific reason, and that's because it's where the graph crosses the x-axis. And as we all recall, the x-axis is at y equals 0. We will look at this slightly different today. So it is called zeros because it's where your y value is 0, and that's a really important algebraic idea. We're not going to make that connection completely today. That's something for a little bit later on in the semester, but today's idea is understanding the terminology, solutions, and zeros. So without further ado, we're going to use our graphing calculator. We know that in our systems of equations unit and first semester, when we just solved with our graphing calculator, when we had equations, I could set the left side of my equal sign equal to y1 and put the right side of my equal sign into y2. So let's go ahead and do that in our graphing calculators now. A couple quick things of review. Make sure you put your fractions in parentheses. The x does not go in the parentheses, and y2 is equal to 0. I like to always start with my standard window, so if you press zoom 6 or scroll down to 6 and hit enter, that'll go to your standard window. And so you can see our function looks a little bit different than it's looked in the past, but it has everything we need. First thing I'm going to do is sketch what I see. I want this to be as accurate as possible, but not precise. So it has a minimum. From earlier in the unit we talked about minimums, and that minimum is in quadrant 3, so I'm going to graph that minimum here in quadrant 3. And the curve crosses the x-axis once on the positive side, once on the negative side. So with my minimum here, I know I'm going to cross my axes here and here approximately, and I'm going to go ahead and sketch that curve. This doesn't have to be exact, but it does have to look very close to what you have in your graph. Make sure you put arrows on the ends of your curve. And then we have our other line here, our y equals 0 graphed in red, which you can graph in a different color, or you can just kind of assume or look at and graph with your pencil right over that axis. So that's the first part of this. For each problem, sketch the graph. Now I want to find and label the coordinates of all points that represent solutions. Solutions, if you recall from earlier in the unit, are zeros. And just talked about that earlier. But also recall from earlier in our school year, solutions of systems of equations, which is essentially what we did since we had something in y1 and y2, are my intersections. So there are technically two different ways I can use my graphing calculator to solve this, but our focus is right now going to be the exact same method that we've been using all year long. As long as you have something in y1 and y2, we're going to look for our intersections. So second, trace will bring up my calculate menu, and I want the intersection. You see you have all of these options. If I choose 0, look, that's our vocab word. That's also going to get me my solution if you follow the directions carefully. And the directions are going to be very similar to when we were finding minimums and maximums. You're going to need a left bound and a right bound, and then you can find your zeros. But for now, let's just find our intersections, number 5. Remember, your graphing calculator is only going to go to the closest intersection to your cursor. My cursor is blinking here. There are two intersections. It's going to go to this intersection. So if I want to start on the left, I like to start on the left. It doesn't matter where you start as long as you get them both. Scroll so you know you're closer to that intersection and hit enter. That gets me my blue curve. Second curve, I hit enter again. That's my red curve. Guess I hit enter a third time. Once it's blinking here and it says intersection, I know the ordered pair is at -4, 0. So I can write my intersection here and come up to my line, and my solution is at x equals -4, my x coordinate. Now I want to find my second intersection. That is, bring up my calculate menu again, which is second trace. I'm going to find intersection again, number 5. But this time, if I just hit enter 3 times, it's going to give me the same point. You don't want to do that. Make sure you scroll all the way over so you are closer to the intersection you want to find. Then you can hit enter 3 times. First curve, second curve, guess. This one is at 2, 0. Which means my second solution, or 0, is at x equals 2. I'm okay if you write x equals -4, comma, -2, or, well, not if you write -2, +2. I'm okay if you write x equals -4 or x equals +2. I'm not okay if you just write -4, comma, 2. I need an x equals in there. Alright, so if we scroll down here and we look at our next example, now this is where the difference between solutions and zeros comes into play. This equation is not equal to 0, whereas example 1 was equal to 0. So that was a y equals 0. So in this example, I'm still finding zeros, but it doesn't have the same connotation, the same meaning, because I'm not making my equation equal to 0. That's something that we're going to focus on quite a bit later on in the semester. We have to get the equations equal to 0. But for now, I want you to know we can do this exactly the same way that we've always been solving these equations with our graphing calculator. I'm going to take this left side of my equal sign and type that into y1, the right side, and I'm going to type that into y2, sketch my graph and find my intersections. Go ahead, press pause, and try that right now, please. So make sure your equations look like this in your y equals. Sketching the graph should look something like this. Make sure your minimum is in quadrant 4. Your intersection on the left is in quadrant 2, and then your other intersections in quadrant 1. And we get a solution of x equals -0.5 for this intersection and x equals 4 for the second intersection. Example 3 is going to look a little bit different. I want you to go ahead, press pause, and try example 3. When you're done, unpause to check your work. So like I said, this looks a little bit different. This is something that we studied earlier on in this chapter, and we talked a little bit about these types of functions, and now you have the ability to look at them in the graphing calculator, sketch them. Go ahead and make sure you find both intersections. And we should get x equals -1 or x equals 3. This might be a problem that you guys have some questions on and need to go over again in class. Make sure you mark that down on the right-hand side if you do. There is only one problem left, and this is going to be a little bit different, but I give you everything you need in here. I'll do the same thing on our quizzes and our tests as well. This is a trig function. You guys don't know anything about trig functions. You'll start to learn a little bit about trig functions in geometry and spend a lot more time on that in your Algebra 2 or Algebra 2 trig class. But for our purposes, we have our graphing calculator. We can solve any function using our graphing calculator. I'm going to do the same thing. I'm going to take the left side of my equal sign and I'm going to put it into y1. 2. Now, Here's your trig functions, sine, cosine, and tangent. So it says SIN, I can just press that button in here. It'll automatically open the parentheses. I can type in my 3x and close my parentheses. Subtract 1. Make sure you close those parentheses before you subtract 1. My equal sign means I go to y2 and I type in -2. Now before I graph this is something that you'll understand a lot more when you get further on in your math career, but the calculator has to be set into a different mode. So every time, and this set of directions will be on your quizzes and tests as well, to remind you, you have to change the mode. First, change it to a radian mode. Mode is right next to second. And if you look 1, 2, 3, 4 down, it says radian degree. Most of the time it's going to be on degree. But for now, I want us to scroll down. And most of the time it doesn't matter for our purposes, but when we're starting to solve these equations, it does. I'm going to click radian, just hit enter. Now I'm going to go back to my y equals. My functions are still in. I also need to change the window, so we've done this before as well. You press window, you have your x min, x max, y min, and y max. For these problems, for our trig problems, I will tell you where to set your window. On our other problems, you might need to adjust the window on your own. So in this case, I ask you to put the x min at 0, the x max at 6, change the y min to -5, and the y max to +5. Make sure you go through all of those steps, and then hit graph. And here's where your function looks like. Go ahead and try to sketch that. So make sure you have 1, 2, 3 maximums, 1, 2, 3 minimums, and that your intersection, you have 1, 2, 3, 4, 5 intersections. So your sketch should look like this, and we do have 5 intersections. So I have 5 solutions, or 5 zeros that I need to find here. So I'm going to do second trace for my calculate menu 5 times. Make sure you scroll close to each one of the intersections. Press pause and try to get those intersections. So a quick rounding review. When I find this first intersection on the left, I have 1.2217305. Make sure we're rounding to 2 decimal places. That's what we said in the directions. Round to the nearest hundredth. That means the third decimal place tells me what to do with the second. 0, 1, 2, 3, or 4, keep the second decimal. 5, 6, 7, 8, 9, I round up. So this gives me a 1.22. If you haven't already, go ahead and find our final 4 intersections. And we get our last 4. Make sure you're checking you got these 4 solutions, that you rounded accurately, and come to class prepared to ask questions.